Let's have a look on the high-level application architecture. We will be starting by creating our Azure Kubernetes cluster and configuring it. And first we will show you how can you deploy a database container inside your cluster, and how can you connect to external database services, whether it's inside Azure, in this case Azure SQL or Azure Postgres or Azure Cosmos database. Then we will show you how can you use Active Directory or Azure Active Directory to manage your access and identities in the cluster. How can you monitor your cluster using Azure Monitor? And we will show you how can you load balance your traffic, either internal or external, inside the cluster. And how can you secure inbound traffic using SSL. This is just one level deeper, just focusing on Azure Kubernetes services and the modules inside of it. And all of here you will see the modules that we will be using and implementing throughout the workshop. Don't worry about the details, we'll be explaining every single module throughout the workshop. Show you how can you create a free Azure subscription. You go to portal.azure.com, and then once you go there you will be asked to sign in. If you have already an Outlook on a Hotmail account, you can sign in directly. If not, you can create one. In my case, I have already prepared an account for this workshop, so I will go ahead and sign in. I just signed in now to my portal, and I will say maybe later. And if you can see here, it gives you the option to start with an Azure free trial. You press on start, and it will ask you to sign up. What's important here that you will be asked to enter your credit card information, but don't worry, Azure just take it to validate your identity, nothing more. So you will be entering your identity information, your phone number, and they will validate it with an SMS. Now it's loaded, so it will ask you about the country, first name, last name, your email address, and once you enter here your phone number, it will validate it and then ask you to enter the credit card information, and then you agree. Now that I subscribe, you will find under subscription that they have added my new subscription free trial, and up to the notification here you will find that it tells me I have 170 credit remaining. Now we will be going to create a resource group. So I will press on this left panel, I will go to resource group, and I will create one. What is resource group? It's just a container, an abstraction layer for all of your resources. Let's go ahead and create a resource group. You will be asked to choose a subscription. In our case, we only have one subscription. We leave it as is, and we enter the resource group name, and you choose a region. It's better that you have a region close to where you live. Let's choose Western Europe, then press review, and then create. It will take seconds to create, then you go to resource group that you just created. If we go back to our application architecture, we will start by creating an Azure Container Registry. Azure Container Registry allows you to build, store, and manage container images in a private registry. We will use it to store our images, the build image of our application. Go to the search bar and search for container registries, and create a container registry. Again, you will be asked to choose your subscription, the resource group. In our case, we only have one resource group that we just created, and a registry name. Make sure to choose a registry name which is globally unique, because this will be the domain name that you will use to connect to your registry. So let's try Kubernetes Workshop Demo, and we are lucky. It seems like it works. We choose a location, Western Europe in this case, and we're gonna leave it as is. Review and create, and seems like everything is okay, and press on create. It will take a couple of seconds also to create it. The validation is passed. You press on create, and we will have our registry ready. This is the overview screen once it's created. We will not be using it for now. What important here to remember is this login server. We're gonna use it later, and also the name of it. So you can see that it starts with the name of the container registry.azureecr.io. Kubernetes is a portable, extensible open-source platform for automating the deployment, scaling, and management of containerized workloads. It abstracts away complex container management and provides declarative configuration to orchestrate containers in different compute environments. Let's have a look at the high-level architecture of Kubernetes. A Kubernetes cluster consists of two main resources, node and master. Let's zoom in inside the node. A node is a worker machine in Kubernetes and may be either a virtual machine or a physical machine depending on the cluster. Each node is managed by the master. A node can have multiple pods, and the Kubernetes master automatically handles scheduling the pods across the node in the cluster. Each small circle here represents a pod. Every Kubernetes node runs at least kubelets. This is a process that allows the node to communicate with the master, and a container runtime environment, for example, Docker. In this case, Docker is responsible for pulling the container image from a registry, unpacking the container, and running the application. Zooming further towards the pod, a pod is a Kubernetes abstraction that represents a group of one or more application containers. When we create a deployment in Kubernetes, the deployment creates multiple pods with containers inside of them, as opposed to creating containers directly. All containers inside a pod share an IP address and port space, are always correlated and co-scheduled, and run in a shared resource on the same node. That means that they can share the volume and the IP address. So to summarize, Kubernetes architecture consists of two main resources, a master and a node. The master orchestrates and the node runs the actual workload in the form of pods that contains containers inside of it, which are the actual applications. We'll create an Azure Kubernetes service cluster. We search for Kubernetes services, and you will see that no Kubernetes service here to display, and we will create a new service. Azure Kubernetes Service is the Azure service to create and manage Kubernetes clusters. As always, we choose our subscription and the resource group we created and the cluster name. Let's choose Kubernetes Workshop AKS as the name. We leave the region as is, the Kubernetes version as is. At the time of recording this video, it was 1.15, the default version, but it might be different when you're watching it. Regarding the node pools are just collection of servers. You can choose up to 100 servers or nodes inside one node pool. And here you can change the size. The size of the node, you can choose it here, but watch out because you cannot change it after the creation of the cluster. We can here choose the size, let's say 2 virtual cores and 8 gigarams, or maybe keep it as 2 and 7 for the sake of demo. And as I mentioned, you cannot change the size after you create the cluster, but you can add new pool and also new nodes. We're going to talk about the node pools in a second, but here you can have 3 as a start, and then later you can add up to 100 nodes per pool. Let's go to next. Here we can see the concept of node pools. Node pools can contain up to 100 servers or nodes, and you can have up to 10 node pool per cluster. That gives you a total of 1,000 nodes inside your cluster. For this workshop, we don't need more node pools, so we leave it as is. Virtual nodes also, we don't use it for now. And then you can see the virtual scale set, and it tells you that the virtual scale sets are required for multiple node pools, but not only this, it's also required for auto scaling, and we will speak about it in a second. But in general, in case you are not familiar with virtual machine scale sets, virtual machine scale sets allows you to create and manage a group of identical load-balanced virtual machines. The number of virtual machine instances can automatically increase and decrease in response to the demand and the defined schedule. It seems like the virtual machine scale sets also required for the Windows support. By default, you have Linux nodes in your cluster, but in case you would like to have Windows support, then instead of running individual virtual machines, you will have to have virtual machine skill sets. We leave it as enabled, and we go to next, which is authentication. So here under the authentication tab, you can create an identity for your cluster. The cluster requires an identity to create additional resources like, for example, load balancers and manage disks in Azure. This identity can be either service principal or system assigned managed identity. This identity can also be used to authenticate with Azure Container Registry that we created in previous video, and I will show you how you can do it later. And for this purpose of the workshop, we will use the system assigned managed identity because they are more or less the same. So managed identities are essentially a wrapper around service principal and make their management simpler. And we will see that we will be requiring the system assigned managed identity for the integration part. Here it tells you the system assigned managed identity is required in order to associate Azure Container Registry. So in order for your cluster to go to your private registry, in this case the Azure Container Registry, it needs an identity. The identity is just the username of your cluster. And for this, you need the system assigned managed identity under authentication. So I will choose it. If you go back to integration, you will see that you can choose your container registry. So here you have the RBAC, role-based access control. We're gonna leave it as enabled because we use it to control user access to the cluster as well as what the user may or may not do once it's authenticated. We leave it as enabled and we go to the networking tab. Now we're gonna configure the networking of the cluster. Azure gives you two options, two models for networking. One is the default Kubernetes model, and the other one is the container native interfaces. And for us to explain it, let's go back to the architecture. You can see here that each pod inside the node gets its own IP address, and the node here also will have its own IP address, which is different than this one. The basic and default networking model of Kubernetes is called KubeNet networking, where the node will get an IP address from the Azure Virtual Network subnet, and every pod here will get his IP address from a logically different IP address range. So these IP address ranges will not be visible for the external world. Then in this case, pods will reach the external world using Network Address Translation or NAT. So the other networking model is called CNI, which is Cloud Native Interface. Sorry, it's called Container Native Interface. And in this case, let's just clear a bit all of this and have it completely new. So in this model, what you will have is that each pod inside your node will get his proper IP address, and this IP address can communicate to the external world. The pod can communicate using this IP address to the external world and at the same time receive information and traffic from the external world. But in this case, each IP address here has to be unique across your whole cluster, and it's part of your subnet. In case you're not that much familiar with Azure Virtual Networking, we will touch upon it in just a second, very high level. Let's go back to our networking and choose Advanced. Remember, Advanced again is the CNI model I just mentioned. It's the Container Native Interface, which gives an IP address to each pod inside your network. And here you'll be asked to create a virtual network. We don't have a virtual network, we did not create it again before. Then here you will see that you have the option to either create a new one, or the system here, Portal, will create automatically one for you. When I was speaking just before about the subnet, so in general, virtual network is just a private network in the cloud. Think about it just like the LAN network in your premises. It has a range, an IP range for the whole network, and it has inside this range, it is subdivided into subnetworks, or subnet for short. We're gonna leave everything as default, but it's important to know that here, well, I think this is a bit too much range, so we can just put it 16, and here we can leave it also default and put the address range at, so for example here, this is the complete subnet here, which consists of 65,000 addresses, and this is the unique address of your virtual network, and the subnet is subset of this. So I can choose to have, for example, a small subnet of 24, meaning that you will have, as mentioned here, 256 addresses for this subnet, which is part of this 65,000 addresses. This is very high level what is the virtual network is. Then you go back and you press OK. And here we have an error, which is good. It's good that we changed the default cluster to explain to you what is this. So the Kubernetes service address range, you understand that Kubernetes uses a master to orchestrate and manage the whole nodes. And for that, he needs to run some services. And these services needs an IP address. And here is the range of the IP addresses that you define. And it tells you the address must not overlap with any subnet IP address range. This one is within the range of this one. So this is 10.0.0.016, and if you go here back to the virtual network, you'll see it's the same range. So it collide. You cannot have this. So what we will do is we can just change this 0 to 1. Sorry, we are here. So we change this 0 to 1. It should be okay. And also part of this is the DNS service. It has to be part of this range. So it's also, let's put 1 here. And I will explain what is this just here when we speak about the DNS name prefix. And finally, the Docker bridge address. Remember from before that the architecture here contains a Docker runtime. And this Docker might be accessed from the AKS cluster. And for that it needs an IP address, and that's what you give here, an IP address range to access Docker from the AKS cluster. So here you have the DNS name prefix. This is a fully qualified domain name that you will use to connect to your Kubernetes API to manage your containers after creating the cluster. The load balancer here we leave it as is. Private cluster also leave it as is. Private cluster just allows the master to nodes communication via private link. So the master will never go to the internet to communicate back to the networks. We'll always communicate via a private internal link. For us, we don't care about it for now. We leave it disabled. And network policy. Network policy is something important in the communication between pods. So pods can communicate to the external world, but what if pods inside the same node or pods inside different nodes inside one cluster would like to communicate to each other? How can they do this? And if you go back here to the architecture, you can see that here you have pod and here you have pod. And what if these pods would like to communicate to each other? And here is the network policy. For now, we will not be doing inter-pod communication. We will leave it as none. And then we go to the integration part. For the integration, the only thing here we need to configure is the connection with the Azure Container Registry, which we created a couple of videos ago. You choose the name of it. And then finally the monitoring. We're going to speak later on the course about the monitoring, but for now we can use the Azure Monitor, which is a service in Azure, to communicate with the cluster. And for that we need to enable it here and choose our log analytic workspace. Don't worry about this, we're going to explain it later, but for now leave it as is. And finally review and create. It's doing the validation now. Once it's done, you press on create and you will be having your AKS cluster. Validation passed. We go back down and press on create. It will take a couple of minutes to create, so we'll pause the video and come back once it's done. In case you receive an error during validation or your quota is not enough, The easiest way to solve it is to just choose 2 instead of 3, and then you review and then you validate. You can see here the validation passed, and go ahead and create your cluster. Be testing the AKS cluster we created in the previous video. For that, you will need some environment prerequisites. You will need some tools to install in your laptop. The first tool is Azure command line interface to interact with the portal resources, and Kubernetes command line client to interact with the cluster. We go back to the portal and then open new tab, and for the first one, Azure CLI install. Search for this and go to the first link. It's a Microsoft documents that tells you how to install it, so go ahead and follow it. Second part is to install Cube Ctl. You do the same, you search for Cube Ctl install, and there is an install and setup Cube Ctl on your Windows or Linux, whatever operating system you are using. So go ahead and do that. I already did it in my environment, so I will be directly using it. We don't need this one or this one for now. And first thing you need to do is Azure login. You need to log in to your portal. Once you press enter, it will open a browser and ask you to sign in. Here you will enter your email and password, and then you sign in. It will sign in and then revert you back to the command line interface. Alright, so you are signed in as, and then when you go back to the Azure login, you will have this JSON formatted response. The first command you need to do, I increased a little bit the font to be able to see. The first command you need to execute to retrieve the credentials of your cluster is AKS get credential, and it has 2 parameters. First one is the resource group. In our case, it was Kubernetes workshop, and the name of the resource, and in this case Kubernetes workshop AKS, and then maybe I mistyped here, workshop AKS, and then we press enter. The command is finished successfully. This command retrieves the credential that you need in order to connect to your cluster. You can view this credential either by going to your home directory. Underneath there will be a new folder called Cube. Underneath of it you will have your config file, or easier, you can use the Cube Ctl command config view, and this one will show you all of the details of your cluster here. So you have the cluster name, the version, your certificates, everything you need to communicate to the cluster. We clear our screen, and then you can play around with the Cube Ctl. For example, if you'd like to know how many nodes or to show the nodes inside your cluster, you can write Cube Ctl get nodes, and it will get the 3 or 2 nodes that you have in your cluster depending on how many nodes you have, and the status is ready. Next thing, we will be creating a namespace. Before I explain what is namespace is, let me do this command, Cube Ctl get namespaces, and you can see that inside the cluster by default you have a default namespace which contains all of your resources, and 3 other namespaces that are used by the master to organize its own resources. Let's say that you want to deploy several applications from different teams or departments in your company to the same cluster. What should you do? Or do you have to spin and create a completely new AKS cluster for this? Namespace comes to the rescue. A Kubernetes namespace is a logical boundary between your resources. So you group all of your resources. It's like resource group in Azure. It's here namespace that groups all of your resources inside a cluster. And every resource inside one namespace must have a unique name, but it doesn't have to be unique across the whole cluster. And like this, you are able to deploy multiple namespaces inside one cluster and at the same time each namespace can be as if it's its own cluster, all small cluster that runs inside your nodes. So by default here you have a default namespace where if you don't specify, if you create a resource in Kubernetes and you don't specify a namespace, it goes to this default namespace. For the purpose of this workshop, let's create a new namespace by the command Cube Ctl create namespace, and then you put the name of it, rating app, for example. Then if you, after it's created, namespace created, you get namespaces, you will find that you have this rating app as a new active namespace. Up until this point, we have created an Azure Container Registry, and we have created our Azure Kubernetes service. And we added a namespace inside of it. We also deployed a virtual network. In this video, we will be deploying a MongoDB inside the AKS cluster. Later, we will be connecting to an external database, but for the sake of this workshop, for now, we will be deploying a database inside a container in the AKS cluster. If we go to the detailed Azure Kubernetes Service architecture that we showed at the beginning, this is the scope here is inside of the Kubernetes service, and inside here, this is the complete deployment of your application, microservice application. It consists of, maybe you can focus on this part is database, and all of this part is the middle tier, and all of this part is the front end. In this video, we'll be focusing on the database, which is this part. We'll be deploying a Mongo database. Before we install MongoDB, let's talk about Helm. So what is Helm? Helm is simply a package manager for Kubernetes. So it allows you to get a pre-built packages or applications and install it into your Kubernetes cluster. If you are coming from Linux background, you are familiar with apt-get install to install packages inside of Linux. You can use the same inside of Kubernetes using Helm. So we go to docs. By the way, the website is helm.sh. It's not under docs, it's under get started. You go to get started, and then down here you find that install Helm. Go to the installation guide. According to your operating system, you choose your code and you just install it. From experience, I think you can do it. I'm using Windows, but if you use Shoko install Kubernetes Helm, sometimes you have administrative or permission errors. So what I usually do, if you go completely down and you press on this experimental Windows, this will download a zip file. And this zip file, you can find the Helm inside of it, and you just have to put it inside your path. So I downloaded it. You don't even have to put it inside the path if you don't want to. You can just press CMD here and you will be able to run Helm. I just wanted to mention an easier step. If you don't want to install Helm in your local machine, you can go back to the portal and you press on Cloud Shell. The Cloud Shell inside the portal already has Helm installed, so we can use it here if you don't want to install it locally. So first thing we need to do is to write this command. I will also provide all of the commands used in this workshop. This is just to configure the Helm to go to the right repo to download the database. So you press enter. Again, we are using Helm as a package manager just to install a ready-made built application, which is the MongoDB that we will be using inside our cluster, AKS cluster. Alright, so this is the command you need to install the MongoDB inside your cluster. So Helm install, again I will provide all of the codes in the resources and all of the scripts. Helm install, rating is the release, Bitnami MongoDB is just the name of the package. And it's important to mention the namespace. Remember that in our Kubernetes cluster, we created a new namespace and we call it ratings app. We have to set three main stuff. So the first one is the username of the database and the password of the database and the name of it itself. So this is the name of the database itself. So it's a rating DP, and let's choose username. For example, we can say Kubernetes user, and let's choose the password that you want. Okay, so let's change password. This is demo, so I can show you my password, no problem. 1 2 3 4. It has to be in a string, and press enter. And Helm now will install it in your Kubernetes cluster. And you can ask, how can I know which Kubernetes cluster I will be installing this into? Remember that here we have a kube config, and this config allows you to choose the right AKS cluster to install it in. And here we have an error. I think we misspelled the namespace. Let's verify what is the name of the namespace. So use Cube Ctl get namespaces, and then we will see here that it's okay. Yes, there is no S here. So if I go back here, and all I need to do is to remove the S, and now everything should be okay. Okay, sounds good. Here the installation is successful. Now we have your database running on the AKS cluster. What's important now here to note is just this DNS. So note it down, we're gonna use it later. We'll be creating a Kubernetes secret to hold the MongoDB details. You don't want your password of the database to be stored in a configuration text file. So we'll be using Kubernetes secret. If you search for Kubernetes secret, you can go to the Kubernetes official website, and it tells you what is it. It simply lets you store and manage sensitive information. Could be a password, could be a token, or public-private key combinations. So we're going to be using and creating secrets in this module. We go back to our command line, and this is the command to create secret. So Cube Ctl create secret generic. This comes from the API from the Kubernetes. And now you put the name of the secret, Mango secret. You choose your namespace, which is always on all of the workshop rating app. And then let's talk about this last part. A Kubernetes secret can hold several items and is indexed by key. But in this case, here we only have the Mango connection as a key value pair. What we need to do now is change the username to the username we choose AKS user, and the password was, if I remember correctly, 1234, rating Mango database, everything is correct. Then we press enter. So this is the username we used before, the password, the name of the database, and the port. Everything is correct. Then secret Mango secret is created. To validate that it was created, let's use this Cube Ctl describe secret, and then you put the name of it, which is Mango secret, and finally you put the namespace, which is rating app. And here, if I don't, yes, I did not misspell anything, so it tells you the name, the namespace, and it contains 64 bytes of the memory. By now, we have created our secret that will be holding the connection string for our Mango database. Remember that we created a container registry in one of the videos before, but up until now, this container registry has no images. If you go down to repo, so under service, you have repository. If you go to repository, you will find that it's no results, it's completely empty. So in this video, what we will be doing is we will be building our image using ACR or Azure Container Registry. But for that, let's install Git. All of the code that we will be using is hosted on GitHub. And we will be installing Git in order to communicate with the GitHub. You search for git install and you go to git csm and you install. I already installed Git on my machine, so in order to verify do you have it or not, you can just write this command, get dash version, and I think it's double dash, and it gives you which version you are installing. Good. First thing you do, just for the sake of organization, you create a directory, and let's call it EKS workshop demo. And you go to this directory. Then what you need to do is first to start cloning this repo. All of the links that I will be using will be posted in the resources of this course. You go to clone or download and you copy this. You go back to your terminal and you enter this command, get clone and the link. This will download all of the front-end files from the GitHub into your local machine. Now, if you list the content, you will see that you have the front-end part cloned inside this directory. Now we change to this directory, and what we will be doing now is we will be using the Azure Container Registry not only to host the image but also to build it. We will write ACR build, and we will provide the registry name, and we will provide the name of the image, the final name of the image that you'd like to produce. For the registry image, we go back to the portal and we check this is the login server. What we need is the name, just the main name. Copy this one, go back to your console and put it here. And the name of the image, this will be rating-web. This is version number 1. We press enter and we now are building the image, and we're gonna directly push it towards the ACR or Azure Container Registry. I got an error because I forgot to put the source location. So in addition to the registry and image, you will have to just provide where should I find the files in order to run and build this application. I will just put dot. That means that in the current directory, and I will press enter. You can see that now it's started to build, and it will take some time for the first time to actually build, download and build all of the images needed for this container. So I will stop the video and come back once it's done. It took about 4 minutes to successfully end. This is only for the first time. Next time it will be faster. We will need also to do the same, but not for the rating web, which is the front end of the application, but also for the middle tier. We go backwards, and what we need to do is get clone, and we're gonna clone the other directory. Again, all of the links will be shared. So get clone, and you clone it into the Kubernetes workshop demo folder. Now we have it there. What we do again, the same. We're gonna do exactly the same, but this time is for the API part. So we go to API. We can even go reuse, yes, ACR build, the same registry name, and here the rating.api version 1, and don't forget the source location and press enter. It will take again almost 4 or 5 minutes, then I will stop the video and come back once it's done. It took actually much less, 1 minute to build. Last thing we need to verify now is that our images are successfully uploaded to our repo. We go back to the container registry, we go back to repos, repositories, and we can see here that we have now 2 images successfully built on the repo. Going back to our Azure Kubernetes Service Detailed Architecture, we have successfully created all of these components. So we created MongoDB, deployed it inside the cluster, and we have created a secret to contain the connection string to this database. This part is not yet done, but we're going to talk about it later. For this video, we'll be focusing on the middle tier, so the rating API. And this rating API, we build its image and it's ready on the Azure Container Registry. So let's see how can we deploy this middle tier into our AKS cluster. Just a hint, this file will be also provided to you in the resources section of the course. First thing we need to create is a deployment manifest file. So you describe the desired state of the workload in a deployment manifest file and use Cube Ctl to submit the manifest file to the deployment controller. And then afterwards, the deployment controller takes care of translating all of this YAML descriptive file into an actual deployment in your cluster. Again, this is descriptive language, YAML, and it describes your deployment. The whole goal of this workshop is not to go into the details of every item here, but for us it's important to understand what is the component of this manifest file. Coming back here, so using the YAML file, I want to tell AKS, please deploy an application called Rating API and deploy 2 pods of it. And this is what is translated here. The deployment name is Rating API and it contains containers with the name of Rating API, and the container has an image, and this image is referring to, if we go back to our portal, just to show you what is referring to, you remember our container registry, and I told you, remember this, like a couple of videos ago, I told you, remember this login server. So if you can see here, it has an API of Azure ACR.io. So going back to our deployment.yaml, you will find here that here you will add the name of your container registry, and Rating API version 1, that's already what's existing under repositories. If you go to repository, here you can find that you have already 2 images. One is the middle tier and one is the front end. We are focusing now on this middle tier. Yes, there's not much information here. So again, what you need here to replace, let me zoom it out a bit. This is the name of your container registry. You need to just put it here. So replace this ACR name with the container registry name. On the Kubernetes website, you will find enough details on every single item of this. What I'm trying to give you is the big picture, since this is not a Kubernetes course. So here, what am I telling in this YAML file? I'm saying deploy this image inside a container called Rating API and expose the container to port 300, not 80. So here you choose whatever port you want. And here is an interesting part. Let's talk about the environment. Remember that if I would like to connect to this Mango database, I would like to have the connection string. Here what I'm saying is, please Kubernetes, give this container access to an environment variable called Mango URI, and the value of this environment value, get it from the Mango secret that we created. And the key is Mango connections. So this is what we created last section. We created a secret. The name of the variable inside the secret is Mango connection, and this contains the connection URI to the connection string to the database. So I'm attaching it to an environment variable called MangoDB. So there are 2 ways of communicating via secret inside the Kubernetes. Either you attach just an environment variable like we do here, or you mount a volume, a complete volume that contains a file that has this Mango secret. But for now, we do it easily just using an environment variable. So finally, the resources part. Each container instance is given a maximum here of 25% of your CPU and 64 megabytes of RAM. The Kubernetes schedule first looks for a node with available capacity and schedules the pod on it. Finally here, the limits, it's just giving the Kubernetes, telling it this is the maximum resource allocated. Do not give him or this container more than 50% of the CPU, and don't give more than 256 megabytes. Just a hint, here if the container exceeds this 50%, it will not be killed, or like process will not be stopped, but if it exceeds memory, it will be stopped and reallocated. Finally, the readiness probe and the liveness probe. So the container exposed a health check endpoint at health Z and port 300. If the API is unable to connect to the MongoDB, the health check endpoint returns a failure. And then you can use this probe to configure Kubernetes and check whether the container is healthy and ready or not. By the way, this is the endpoint that will be used to also check if the container is up and running or not, and if not, then Kubernetes will be able to kill it and restart a new one. And that's how Kubernetes maintains your platform up and running. That's it. So again, it's just a YAML file with some syntax. Syntax, you can always learn it on the documentation side, but it's important to understand the high level. What is this trying to do? Then we save it, and let's save it as rating-api-deployment.yaml. Let's remember where was, yes, it was here, AKS workshop demo, and let's save it here. And let's go back to the command line. I'm back at the command line. Let me go back to the AKS workshop demo folder. If I list it, I have my YAML file here. What I need to do is use Cube Ctl command line to deploy this file into the AKS cluster. The command we will be using is Cube Ctl apply. Then you put the namespace, which is rating app. And finally, you put the rating API deployment YAML file. You press enter. The command apply is used to update an existing deployment. And if it's the first time to create it, then it also can create a new instance if it doesn't exist. If it exists, it updates it. But you can also do the same with, instead of apply, you can just put create. So here you can say that deployment.apps rating API created. Let's validate our deployment. So Cube Ctl get deployment. It gives you the states of all of the deployments in your cluster. Deployments. And you can see once it's done, no resources found. Yes, so that's very important, and we're going to do it next in the next videos as well. You always have to specify the namespace, which is in our case app, because if you don't, it will only look at the default namespace. So again, remember that we have Cube Ctl get namespace. And then you have default one and rating app. So any command I use, for example, get deployment, it will be executed on the default namespace, which we don't have any resources in. But if I specify the namespace, then it will show me that now I have two deployments, rating MongoDB, our database, and rating API, our middle tier. Last part is to show you kubectl get pods. Again, you put the namespace that we have, which is rating app, and here it gives you the name of the pods itself, and the pods contain the containers inside of it. Yes, it's rating app like this, and it tells you that we have one which is running. Oh, that's actually interesting. So here the status is image pull back off. So the MongoDB is running, no problem with it. But here is a problem with the image pull, meaning that the Kubernetes cluster cannot pull the image from the Azure Container Registry. We go back to our application architecture. You see here we have the Azure Container Registry, and here is our Kubernetes cluster. Kubernetes cluster need to go and access the Azure Container Registry to pull images, and it uses Azure Active Directory to authenticate. But we did not give permission to the Azure Kubernetes cluster to access the Azure Container Registry, and that's what we're going to be doing now. Let's go back to our portal. Under the Container Registry, there is access control. Press on it, and then here you are able to add role assignment. Press on this, and what you will do here is you will select the role. The role will be ECR pool, and let's search for Kubernetes. Then you choose agent pool and you save. And once this is done, we can go back to the terminal, and you will see that Kubernetes has access to pull the images from the container registry. Now if you get let's first get the deployments that we already have. Deployment. And let's delete the original deployment, the rating API. So Cube Ctl delete deployment, and we choose the namespace rating app and the name of the deployment, which is rating -API. And this will delete the deployment, missing it in, and it's deleted. Now what I need to do is apply the deployment again. So this is the right command for this. And now if we write Cube Ctl get pods, and we specify the namespace rating app, we'll see that we have finally the rating API pod. It's not yet ready, it will be ready. We can actually do -watch, and we will be always getting the up-to-date status. Now it will be ready after a second, and the status is running. So we have successfully managed to give the right access to the Kubernetes to pull the image from the Azure Container Registry. So up until this moment, we have our rating application, and we have it deployed in our cluster as one pod. But how can I access this pod? Up until this moment, there is no internal or external IP address assigned to it, so I cannot access it, I cannot talk to it. And here comes the concept of services inside Kubernetes. What is a service? A Kubernetes service is an abstract way to expose an application running on a pod. And the purpose of it is to enable communication between this pod and other pods in the node, or other pods in different nodes, or to the external world. Let's go ahead and create our service. Here, the deployment file will be much simpler. So again, now we should be a little bit more familiar with this YAML deployment file. Remember the old one, the kind was deployment. Here, I'm telling that the kind is service. So I'm deploying a service. The name of the service is rating API, and selector of the app. Let's talk about this. How can I know which application this service is associated to? I know this via the selector. So I go to the application of the name of rating API. If I go back to my previous deployment and I go to the app here, label app, the rating API. So with this selector, I know which application am I exposing, or which container inside the pod am I exposing. So next is protocol, TCP, straightforward, and port 80 and target port. What's the difference between port and target port? So this is a little bit sometimes confuses people. Port is the external world. In this case, the pod, when it's inside the node, all the traffic coming to the node on the port 80 will be directed to the port 3000 of the pod. This is the mapping. This port reflects the external world communication, how I see it from outside. From outside is port 80, and from inside it's port 30. So this will be routing. I receive all communication on port 80 from outside, and I route it to port 3000 inside the container. And finally is the type of the service. There are multiple types for each service. Cluster IP, it just means that gives this pod or this service just an internal IP. Do not allow external communication to this pod, rather allow only communication from the internal network. So we will save this file, and let's save it in the same directory and call it code rating API service, all dashes between .yaml. Again, these files, along with all of the other files, will be provided to you in the resources. Going back to our terminal, what we need to do is to do the same. You remember the apply command, but in this case, instead, so the same, apply namespace and the same namespace, and what I will be applying now is the code rating YAML file. And you see service created. If we now use Cube Ctl get services namespace rating app, then we will get all of the services inside our cluster. You see we have a service for the MongoDB and a service rating API that we just deployed, and now we can see the API. There is no external API because it's only a cluster network scope, and it's a TCP protocol on port 80. So now that we have created our middle tier, it's time to create the front end. So what we have now is the middle tier is created, running inside a pod. The MongoDB is running inside a pod in our cluster, and they are communicating to each other. And there is a service attached to the middle tier with a cluster IP, meaning it's an internal only service. You can only access it through the cluster. But now we would like to build our front end part, which will allow traffic, HTTP traffic, to reach it from the internet. So let's go ahead and do it. So again here we come back to our deployment YAML file. It's gonna be the same like our first one, which has the kind deployment. That's what we use to deploy our middle tier. Here we will be deploying our rating web. So we have a deployment of name rating web that will be selecting a rating web application. And this rating web application, you will find it here with this information. So exactly the same things. I'll be providing you this file. What you need to do is to replace this with the Azure Container Registry name. So we go back to our portal and we go home. Let's try to find the Container Registry name, and here is the name. We copy the name and then we go back and replace this with it. And then let's talk about the rest. So nothing new here. Here we don't have to actually define an environment variable like we did, because it doesn't want to communicate directly with the database. It will be communicating through the middle tier rating API to the database. So we're just saying that please expose it to port 8080, and also the same resource request and limits. So nothing here else to explain. So let's go back to our console and deploy this YAML file. So first let's save the file. Again in the same place, choose the name you want. I choose rating-web-deployment.yaml, and saved. I go back to my console here, and we're gonna use the same command. Let's choose the right, it's not this one. Let's first check what's inside, and cube apply. So rating web. Yes. So here, maybe a small trick. You know that every time we have to identify the namespace attribute and put it to rating app. This is the name of our rating space. Otherwise, it will deploy it in the default namespace. But let's first deploy this one. There is a trick that you can find it inside. This is now already created. If you go back to Kubernetes cheat sheet, there is a complete set of all of the commands that you can use with Kubernetes. So you just have to search for Cube Ctl cheat sheet, and then you will find it, the first one. What's interesting here is you can find, if you search for namespace here, so set a context utilizing a specific user. No, that's not this one. This one, yes. Permanently save the namespace for all subsequent kubectl commands. So let's copy this one. What this means is, if I go back to my command line and put rating app as my namespace and press enter, I no longer need to specify namespace in my commands, because my new default namespace will be the rating app. So for example, if I do kubectl get pods, I no longer need to provide namespace. I will already get my pods. And here there is an issue with this one. Let's go ahead and see. Alright, so I went to my portal and I found that the application name is rating version 1, rating without S. And here you can find that we have S, so that's why there is a problem of pulling the image from the container registry. So I remove this S. Also important here that you also remove the S from this rating app in the link. So this is just an environment variable called API, and the application expects to connect to this API. So once this web front end starts, it needs to connect to the middle tier, right? And this is the environment variable that it will be using to connect to the middle tier. We go back to our console, and what we do is delete the deployment. Again, I know the name here from here, the name of the deployment. Okay, I didn't save it, so let me save it. And I go back to the console and I apply it again, and it's created. Then I get pods and everything is up and running. Back to our architecture, we deploy the rating web inside one pod, and now there is traffic going between the middle tier and the front tier. What is needed here is to create a service, and this service will allow the public traffic to get inside the cluster, and that's why we're gonna choose the type load balancer. So what is service of type load balancer? So very simply said, it just creates a public IP address to the front end and allow public traffic to go through the cluster. If you would like to have a little bit of details under the hood, it creates a load balancer. It creates an Azure load balancer and a public IP address, assign them to each other, and allow public traffic to go inside the cluster. Again, so same file that we use for the service regarding the middle tier, we will use with changing of names and changing of the ports. So the type will be load balancer. The traffic will come at port 80 from the outside world and mapped to port 8080 inside the pod. So we save the file in the same path. I choose the name rating-web-service.yaml and I save. I go back to my console and I apply the file. What was the file name? Rating web service. So rating web service, and I apply it. It will take a couple of seconds to create the service. It's created, and I cleared my screen, and then what I will do is I Cube Ctl get services, which will show me all of the services which were already deployed in the previous videos. You can see here we have the rating API service with a cluster IP type and MongoDB cluster IP type, meaning only internal. You can reach it only with internal. And you can see here you only have a private IP address. And here we only have external IP address only for the rating web front end service of type load balancer. Now it's finally the time to actually test our application. You go to the browser, open a new tab, HTTP, and you put the IP address, and voila. Here you find your rating application up and running inside your AKS cluster. Very good so far. So finally, in last videos, you were able to see the outcome of your work on all of the previous sessions, and you're able to access your application, which is hosted on AKS cluster, via publicly accessible IP address. So if we go back to the application architecture, we are done with all of this part. So all of this part is already done. And now what we will be focusing on deploying something called an Ingress. Since as of now, the traffic comes and bypasses this Ingress and goes directly to the service of type load balancer that we deployed in our cluster. So now let's talk about Ingress and why do we need it. Before explaining what is an Ingress, let's talk a little bit about layer 4 and layer 7 load balancing. If you are familiar with the OSI model, you would understand that it consists of 7 layers. But if you are not, don't worry. The purpose of this video is to just tell you that the service we created before of type load balancing or load balancer is a service of layer 4 load balancing type. So it's only aware of the transport layer, meaning that it only understands TCP and UDP protocols. And this implicates that it only sees the IP address. It doesn't see the URL on the HTTP level. But don't worry about all of these details. What is important to understand now that you need a layer 7 load balancer, not a layer 4, in order to be able to understand the HTTP protocol. That's what you need to know. That being said, let's talk about the Ingress. So simply said as well, the Ingress is just a top load balancing layer on top of the service. So the service itself is load balancing multiple pods, but all of these multiple pods contains one application. But what if you would like to deploy a new service that contains multiple pods behind of it? That means that this will have an IP address and this service will have another IP address. But from the outside world, the incoming request here will have to understand and know this IP address and know also this IP address. But Ingress here provide an abstraction layer that understand HTTP and HTTPS traffic and will be able to route based on the URL, meaning that it will be rating, for example, /service1, and this will be routed via the Ingress towards the service 1. Let's say this is service 1. And then if I get the same URL but instead service 2, then Ingress is smart enough to map it to the service 2. You can also use the Ingress for other stuff like TLS termination, which we'll be talking about it in further videos, and also it can act as a reverse proxy. Now we are back in our terminal, so let's create first a namespace. Since we are deploying the Ingress outside of our application, let's keep it clean and put it on a new namespace. We call it Ingress. Now that we created it, the second step is to actually create the Ingress resource itself. We're gonna use Helm again here, which is the package manager for Kubernetes to install the Ingress controller. Second thing we need to do is just to refer Helm towards a stable repo to make sure that we are getting the latest stable version of our Ingress, not a non-officially released one. We just use Helm repo add stable and then the link. Don't worry, all of these links will be shared in the resource files in the course. Just before going and installing the Ingress controller, we were speaking about Ingress here, and now I'm speaking about Ingress controller. How come? So Ingress is just the concept. It's a resource that Kubernetes itself, the original implementation of Kubernetes, did not provide a one service or an implementation to the Ingress controller, but it gives you the idea of having an Ingress, which is a load balancer on layer 7 on top of the services. But you yourself have to implement it. But how can you implement it? Simply here you can see that controllers, there is a lot of controllers in the market that already supports and also implements the Ingress controller for you. In this workshop we will be using Nginx. So let's go back to the terminal and see how can we install it. We're back to our terminal. Again, Ingress in Kubernetes is just a concept. Ingress controller is the implementation of this concept. And we're going to use Nginx, which is one of the implementation of this concept inside our Kubernetes. So now what we're going to do is use Helm to install this Nginx. I copy pasted directly the command and will be also sharing it with you, of course. And it's a little bit too much, but I will just explain it very high level because it's actually simple. It's just too many arguments. So we are calling Helm here. We are asking Helm to install Nginx Ingress. Nothing fancy here. We are telling it to get it from the stable repo that we just provided in the previous command. We are giving it a name. Here, the namespace, we are identifying the namespace, which is Ingress in this case, which we just created here. And we have multiple arguments here that we can speak about. The first one is the controller replica count. So what I'm just saying is install 2 replicas or 2 pods of this Nginx. So this is just for the sake of availability. Install 2 instances of it. And here, not selector here or not selector here. This is just regarding, I'm telling it, please the controller, it choose Linux, only Linux machines, not Windows machines underneath, because up until this moment, only Ingress can be deployed on AKS on Linux machines. Alright, so we press enter and let our Helm do the magic. Again, if this is too complex for you, don't worry, I'm going to share it with you and you don't have to really know it because you can always copy paste it, but you just need to understand the concept behind it. Now, the Ingress is, you can see here that the Nginx Ingress controller has been installed and it takes up to 5 minutes actually to get an IP address. So we're going to wait a bit and come back. Now I see that I have now an external IP address assigned to the Ingress controller or Nginx controller. So while I check the status just by copy and paste, if you go up, you can see that it may take some couple of minutes, but you can always watch the status by doing this command, and I just copy here the command and I just checked it, and that give me the outcome here. So nothing else to do here, so Ingress are ready to be used. But remember, we go back to our service. This is the rating web service, the front end of our application. It has a type of load balancer. Then what we need to do, because now what happens is that our cluster is exposed to the internet not only via the Ingress controller but also via this service. So you have 2 endpoints for your service. So what we need to do is just change this to cluster IP type. Let me just check if it's the same. I didn't do it. Yes, let's just copy from this. It's all capital. And then put it here, save it. And then I go back to my console. First, I go back to my AKS workshop. I clear the screen. You cannot, ideally what we can do, this is just the IP address. Ideally what we can do is just use the command Cube Ctl apply and then the name of the deployment. So apply first deployment, the name of the deployment, which was rating web, and then -f and the name of the file, which is rating web service. But the problem here is that you cannot change type while the service is running. So what we need to do now is we go back to the terminal, and first we have to delete. So we can delete this first and redeploy it. Yes, now deployment rating web not found. Yes, okay, so sorry, it's not a deployment, it's a service. Service. And then again, not found. Maybe ratings. Yes, okay. So now that I deleted it, let's apply Cube Ctl, and then you apply the new deployment file, which is rating web, the service one. It should take seconds to be created. Yes, it's created. If we go back to the high-level view of the Ingress, you notice that you can have multiple services behind one Ingress. So how can I know which request to map to which service? Remember when I showed you before that you can have \s1 in your URL, or you can have in your URL s2 in your path. So I need to configure, for example, Ingress to route this request to service 1 and this request to service 2. For this, I need something called Ingress rules. And that's what we'll be doing now. But in order to do Ingress rule, the container of it, or like the umbrella, is Ingress Resource. So I need to create Ingress Resource, and inside Ingress Resource you have one or many Ingress rules. So let's go ahead and create our Ingress resources. So again, yes, you guessed right. For any resource you would like to deploy to your Kubernetes cluster, you have to have a YAML file, a manifest or a deployment file. Here, the kind of Ingress. Metadata, so this is the name, which is rating web Ingress. And here we're just saying which implementation we are using, which is Nginx. And here's what's important here is the rules. So as I mentioned before, this is an Ingress resource, and inside this resource you have multiple rules. And here the rule, we only have one rule here, which is based on path. So what it does, it's just URL path routing. When you receive a request with this format, you will route it to this backend. This rating web service, we created it before. You remember, this is the web service that we changed it from load balancing IP to cluster IP. And it expects traffic on port 80. So here what we are saying is when you receive a URL path starting with this DNS name and has a path like the default path and on port 80, please Ingress, please route it to this service. So now what we need to change is, as mentioned here in the comment, is that you have to put here the Ingress IP address, and I will show you how to get it now. Here, don't worry about this. This is just a DNS name, .nip.io. This is a wild DNS name that you can get it for free. Of course, you can put here instead your DNS name, your custom DNS name. So we go back to the console and we do Cube Ctl services. You want to get actually the service, so we have to put get before, and then you put the namespace here because it's a different namespace than our default one now, which is the rating app. And rating, it was, I think, Ingress, yes. So here you will get the name of the IP address. You better copy it. Let me first save the file here. You save it with any name as well. So I'll save it with rating web Ingress. And I go back to the console. Let's copy this external IP address go back and replace the Ingress IP address with this one. So we are all set now. What we need to do, let's save the file, go here and deploy it, Cube Ctl, apply, and back. We have also here to specify the namespace, Ingress. Now I tell you what, let's leave it in the default namespace, and you choose the name of the deployment file, which is, it was web Ingress, I think, yes, and you apply. Once it's done, the only thing which is missing now is that you go to a browser and you test it again. And voila, here is your web application up and running. So to summarize, now we have almost deployed everything here except for this one, which we're going to talk about it next video. But now we started the video that the traffic is going bypassing the Ingress and going directly to your service. Now we have managed to deploy an Ingress. An Ingress contains Ingress controller, and this Ingress controller contains two pods, or are deployed in two pods, and it contains a routing rule that routes all of the traffic that comes to the main DNS towards the main backend service here. So with that, let's verify that here we cannot anymore access the service via the internal rating web service. It will die, it will not reach it. And here you can only access it via the Ingress controller. Our website is up and running, and we are using the Ingress instead of the service of type load balancing to access our cluster. But up until this moment, if you go to Chrome and navigate to website, you will find this small indication of it's a not secure connection, meaning that it's only HTTP. But it's important for the online security and privacy of user data that you always, in production ready environment, that you always support HTTPS. The good news here that the Nginx Ingress that we configured last session supports TLS termination and provides several ways that we're going to show to retrieve and configure the certificate. If we go back to our architecture, you will see that in this video we will be deploying Certification Manager, which is a module of Kubernetes that is used to manage the life cycle of the certificate. We're going to use a free service called Let's Encrypt as the certificate authority, and we will enable not only the normal HTTP traffic but also the HTTPS traffic towards our cluster. First thing, to start clean, we need to create a new namespace. We're going to call it Cert Manager. So Cube Ctl, create namespace Cert Manager. And Kubernetes will tell us in a couple of seconds, yes, it's created. Second thing, we will be using Helm again. Remember, Helm is just a package manager for Kubernetes. We'll be using Helm to install the actual certification manager. Here is the command line. So Helm repo add. We're just adding a repo for Helm. And don't worry, again, all of the command lines we're going to be sharing in the resource files. And then, yes, okay, I have to go because I did not add Helm inside the path of my CMD. I will go back to Windows where I already installed Helm. So if I try again now, it will work. Helm repo add. So I add this repo of shards. Shards, just the packages inside of Kubernetes, and then I will do Helm update. It has been added now to repo. So Helm repo update. It will make sure that we get the latest out of this repo. And once it's done, we will be installing the shard, the certification manager. Done. Okay, so before we go to the next step, I would like to explain something in Kubernetes called CRD. What is CRD? CRD is Custom Resource Definition. If we go back to our architecture, like high-level architecture of Kubernetes, remember we have master and we have a couple of nodes. And the master exposes certain APIs that we have been using Cube Ctl to create, to deploy, to delete. This is all built-in APIs that Kubernetes exposes. But Kubernetes has an amazing extensibility that you can deploy one CRD or multiple, and this CRD is custom resource definition. You define a new API and you deploy it to Kubernetes master, and what happens is that you can use Cube Ctl to communicate with this API. Think of it as a way of just extending the native or the built-in Kubernetes APIs. The Cert Manager is one of those. So for us, in order to be able to use the Cert Manager module in Kubernetes, we have to deploy our own CRD. So let's go back to the command line and do this. So here's the command. So we are telling Kubernetes apply. It's like a deployment, this file. So if we go, we can just copy paste this, copy it and go back to Chrome and open new link. And this is just in GitHub. It's hosted. This is the CRD that you need to deploy the Cert Manager. So you see here the kind. It's always the same. This is the manifest of Kubernetes, always the same. Status API version, kind, which is CRD, custom resource definition. And this is just, you can find it, it's built in, you can find it online. So this is not something that I write or you have to write when you're developing. You just define, you can define your own resource definition, but this Cert Manager is used by a lot of production Kubernetes clusters, so you can find it online. So that's why when you go back to the command line here, don't feel like scared from the long command here, just Kubernetes apply, and then you can save this file locally, and then it will be as a YAML file normal locally, and then you don't have this long command. So I'll press enter, and it should now apply this custom resource definition, and then I will be using Helm to install the certification manager now. Let me first clear the screen, and then I will paste the command. So again, we should be familiar now with Helm. So Helm install Cert Manager. This is the name, and here is the namespace Cert Manager that we just created, and we're telling them which version to use. Press enter, and once this is done, we will have our certification manager in our cluster. You can see now it's deployed, successfully deployed. What we can do is we can verify it's working. Cube Ctl get pods. Remember to add the namespace, since it's different now. So it's Cert Manager, and you will see in a second that, okay, maybe I misspelled Cert Manager. Yes, and here you can see that you have a couple of containers or pods already in the running state. That validates that you have successfully deployed your certification manager. Okay, so this part is done, but what's needed now is to actually inside the cluster be able to interact with a certification authority. So as I mentioned, Cert Manager will ensure that your website certificate is valid and up to date, and will renew certificate automatically to make sure that it will not expire. But for that, you have to define something called cluster issuer. This is just an interface, because I told you before that you can have Let's Encrypt, which is a non-profit organization that issues for free certificates, but you can also have your own signed certificate, or you can use another service. So certification manager is there, but the cluster issuer tells the certificate manager which certificate authority you will be using, and it will be the interface to communicate and download and do all of the management of this certificate. So now we need to create cluster issuer. Any resource in Kubernetes needs manifest file. So as the cluster issuer. So it's a kind of cluster issuer. This is the interface, and we name it Let's Encrypt. And it doesn't have a lot of variables or attributes here. You have the server. This is where should I get the certificate. Here you put your email, actually the administrator email. And the others is just straightforward. It tells you just this is an Nginx Ingress, and there is nothing more to discuss here. Let's save the file. We call it cluster-issuer.yaml, and we save. And then we go back to our terminal. The same, we have to apply. So Cube C, let's go back to our working directory, and Cube Ctl, maybe I will clear the screen, write it up, Ctl, apply, and then you have -f, the name of the file, which is cluster issuer, and you apply it. This will apply it towards the normal or default namespace, which is rating app, and here you can see that it is created. Now that we deployed it, let's go back to our Ingress. It was here as rating web Ingress file, and we have now to tell the Ingress that we are not only doing HTTP, we're also doing HTTPS. For that, what you need to add, so before rules, between specs and rules, you put TLS. So let's make sure it's correct and the right indentation. So here host, the front end name, and the secret name. So the front end here as well, you will be removing this and put the IP address, which is 51.124, the same one down, 151 and 26, and that will be the Ingress for HTTPS, because here I'm telling TLS. And last thing you need to do here is you need to tell it that I'm using the cluster issuer. Actually, you need to tell it first that you are using cert manager.io, then you put cluster issuer and the name of the cluster issuer that you have it here, which is let's encrypt. So you're just referring here cluster issuer that you deployed, the name of it, and you're saying it's of a type of certification manager type. You save it, then you have to update your configuration towards Kubernetes. We go back to the command line, Cube Ctl, apply, you force the application, and it's called ratings web Ingress, if I'm not mistaken. Yes, let's put I here. Yes, so, and should work just fine. Okay, maybe we missed the indentation a bit, so here it should be just like this. We save it, we go back, we apply it again. Now, yes, when it takes time, it seems like it's working. Then this will update the configuration of the Ingress to add the HTTPS support. Perfect. Last thing we need to do is to validate that our certification is retrieved from Let's Encrypt. So what we need to do, let me go back first here. What was the name? Yes, so here what we added is, this is the host URL and this is the name of it. So let's go back here and do Cube Ctl describe and the name of the interface. Seems like there is a typo here, describe. And we deployed it inside the default namespace. Rating web serve describe, okay. Yes, we need to provide it's a cert. Yes, perfect. Before checking did we get the certificate or not, I just noticed that I have a typo here. So this should be exactly the same like this one. So makes sense. So 51, I saved it, I already did this. And what you need to do if you did the same typo is you just have to apply it again. And once you apply it, it will be configured. And then let's wait, it's gonna change it of course because I did it already. When I describe it already, you can see that it's already issued. So now last thing you need to do, we go back to our rating application. Remember this one, it was not secured. If I open new tab and then HTTP, yes, it's already there. I go to it, you will notice this small icon. It's a lock shape icon. If you press on it, you will get the whole information about the certificate. If you press even on the certificate, you get it's issued by Let's Encrypt, issued to the host name and the validation from 2. Alright, so by that we have managed to construct an HTTPS connection to your rating application. As the popularity of your application grows, the application needs to be able to scale up and down to manage the demand change. You have to ensure that the application remains responsive as the number of rating increases and decreases. In this video, I will show you two things. First, how can you use the Kubernetes horizontal pod autoscaler to increase the number of pods to meet your demand? And also, moreover, how can you use the Azure Kubernetes Service cluster autoscaler to increase the nodes inside your cluster? First, let's talk about HPA or horizontal pod autoscaler. Remember that the node can contain one or multiple pods, and each of these pods has a set of resources which is limited according to the deployment file of this deployment. So if you go back to the deployment file that we used to deploy, for example, the rating API, you remember that we had a resource section and a request, and this is what this pod needs at minimum to actually be deployed in this cluster. So you have a CPU and a memory request, and you have a limitation as well. So this one cannot take more than half of the CPU, of the virtual CPU that you have, and it cannot have more than this memory. But what if I need more than this for my application to respond properly? That's where the HPA comes handy. So HPA allows the AKS cluster to detect when your deployed pod need more and more resources based on a metrics that you define, such as, for example, CPU or memory. And HPA can then schedule more pods into the cluster to cope with the demand. So how can you configure it? There are two ways. The first one is by the command line, which I will show you right away. And the second one is using the deployment. You remember everything in Kubernetes can be deployed via a manifest file. So let's start by the command line. So first, let's go back to the terminal and check Cube Ctl get deployment, just to make sure that we have everything up and running. Yes, so we have the rating API, the rating MongoDB, the rating web, and we have only one available here. Good. Then we can use this command, which is Cube Ctl autoscale, and then you put the deployment name. And you can choose which metric they can use. So here we can use directly CPU percentage. We say it's minimum 50%, and then the minimum amount of pods in my node, it's gonna be 1, and the maximum will be 10. Actually, it will not be only on one node, it will be across nodes. But let's not do it via the command line here, and I'll show you how can you do it via a manifest file. So here is the YAML file that we used to deploy the horizontal pod autoscaler. Again, it's the same API version, and then the kind, here in this case, it will be horizontal pod autoscaler. The name of it, you can choose the name that you want. And in general, it tells the same message that this command line does. Here it tells Kubernetes to deploy HPA, which is horizontal pod autoscaler. when the CPU percentage is more than 50, keep the minimum 1 and the maximum 10. So play around between 1 and 10 to maintain the CPU percentage on average of 50. Here, what you have here is the same, but written in YAML file. Minimum replica, which is the minimum amount, maximum amount, so 110. Metrics based on the resource. The resource is CPU, utilization, and here is 50. But let's maybe put this instead of 50-30 to trigger the scaling up faster. So we're gonna save the file again. Let's name it rating hpa.yaml. You save, and we go back now to the terminal. What we can do now, it's a simple deployment. So Cube Ctl, apply, deploy. We don't even have to write it, we just -f and rating hpa.yaml, and it will deploy it to the default namespace, which is rating web, and here is created. Let's try to kubectl get and pods, and you can see that it's still nothing more. Rating web is the same because the requests are not still that much for the HPA to be triggered and to deploy new pods. So let's do some trick in order to imitate as if you're receiving too many requests in your application. There is one simple trick that you can do first, which is simply here you change the number of the minimum replica to, let's say, 3, and you save the file. You go back to the command line and you do the same. So you deploy this change. Once it's deployed, the HPA will detect that we only have 1 pod, and he will make sure that we have at least 3 pods. So now when I press again get deployment, you can see that we have for the rating API 1 out of 3 is ready because it's still ongoing, but we have 3 more pods that are running in our cluster. Let's do again get more deployment. We have 3 pods. Let's go get the pods themselves, and voila, you can see that rating API has at least 3. So here you can see that HPA completely managed the scaling up. Okay, good. What you can do also is you can manually scale regardless of any metrics. You can manually scale up and down your deployment, meaning that I can use this manual command Cube Ctl scale replicas, and you provide here the number of pods that you would like to have, let's say 5, and you can provide the name of the deployment, which is rating API. It was S, I think. Yes. So here it will tell you that it's scaled. Give it some time. Yes, it is scaled. Cube Ctl get pods. You'll find that here you have rating API count of 5 pods now. And you can also use the same command to just deploy to scale down as well. So let's do it 1 and do scaling, get pods. It's terminating. Again, it's terminating all of them, and after a while it will become only 1 pod of this deployment. Let's go back here and make sure that we only have 1 in order to be able to automatically test it. And here let's apply this new configuration. We go up, it was that far, okay. Then now we will only have 1 pod of the rating API. What we need to do now is to generate fake requests to the application to test the auto-scaling capabilities of the pods, of the horizontal pod auto-scaling. How can we do this? Let me show you. If you just Google Kubernetes auto-scaling, you can find here this command, which gives you a sample of how can you do a load testing on your pods or on your cluster. So what I will be doing here, I will just be copy pasting these 2 commands. Here it runs a pod load generator, which is, this is the image of it, and it does a command while true, like always ask for this, always call this API here, always call it send it request non-stop, and this will increase the load, and you will be able to see the HPA, or like horizontal pod autoscaler, scaling up the pods to meet your demands. So let's try this. I open a new command line because we're gonna use the other one to actually show you the command how the pods looks like. I will copy paste here, so nothing to change here. Press enter. This will just deploy this image inside a pod and allow us to access this command line, which is just a busy box image. I go back here and I copy the rest of this command and paste it here. Actually here what you need to do is to change this to your front end. So how can I get front end? This is our website, so I go back here. This is the website and I copy the link. I go back here, I paste it here. But I'm gonna be testing an API existing in the code already. It's called API/load test. So once I run this, it will go like non-stop. So what I will be doing, I will just be adapting a bit the screen. So before hitting enter, I adapted a bit the screen in order for you to be able to see how it will go. Now, done. Yes, it's non-stop now, sending requests. And here I'm able in another session to cube get pods. You can see here that actually here you need to leave it a bit, like 1 minute, 2 minutes, in order to be able here to see the status. So I will pause the video and come back when it's working. Maybe let's make a small trick for the sake of this demo. Let's make it a little bit smaller. Here I do it 20, and before it was 30, now I do it 20% to make it faster, to scale it up and down faster. And what I will do here is I will need to apply, so Cube Ctl apply this configuration, and once it's done I can already start this one. First let me show you Cube Ctl and you get HPA, and here you can see that it's let me make it a little bit bigger. A rating API HPA that I just deployed, it has a target of 20%, minimum 1, maximum 10 pods, and currently we have replicas of 3. What I will be doing now, I think I already terminated, not this one, I already terminated the pods here. Yes, alright. So what I will be doing is let's scale it to 1. Meaning that it will be only one rating API pod working. You can see this one is terminating now. So here HPA, I cleared the screen a bit. If you get the HPA, you will see at 16% and you have one replica. Again, all of this, watch out, because all of this I still have my load testing working, and now you will find that it's increasing the pod replicas here. Yes, so here it's 3 replicas because it went to 46%. And if now I try to Cube Ctl get pods, I will see that I have now 1, 2, 3 pods. Rating API 1, 2, 3, and one which is 12 days. This is a long time ago. We never killed it, but now one is 30 seconds and another one is 30 seconds, which were just created by the HPA to match this demand. And now, ideally, if you get HPA again, you'll find that the demand, after a while, it will go down again, and the 3 pods will be there enough to match the demand. As I showed you, horizontal pod autoscaler helps to scale out with new pods as required to meet the demands. But eventually, the cluster will run out of nodes to accommodate these new pods. And you will see scheduled pod in a pending state, and I will show you now in the demo. And the solution for this would be to use the cluster autoscaler, which doesn't touch the pod numbers, but increases the node numbers, the actual resources, the servers in your cluster. I'm back here to my command line, and then what I will do is Cube Ctl get pods. And I missed the S, maybe it will work. Okay, so here you have the main pods, the database, the API, the web. You can see that also the HPA is stopped since I stopped my load testing. Then there is no need for extra replicas, and we only have one replica for the API layer. So get pods again. What we need to do now is here you can see the status is running. I would like now to show you how, if now I would increase the amount of pods to a certain extent that the current servers will not be able to handle, then it will be, instead of running state, it will be pending state. But in order to show you this very fast, what we will need to do is to just simply fake it inside the deployment file. Remember here, this is the YAML manifest deployment file for the rating API. We had resources request of this amount of the 20% of the CPU. So now what I will do, I will just ask more. I will ask 100, like the 1000, the complete CPU power, and also I will increase the maximum limit. Like this, I can easily, with 2 or 3 pods, I can already show you how it will end up in a pending state. So I go back to the console, and what I will do, I will have to apply this new configuration. So it's rating API deployment. Once it's done, then we will see the pod is, there is a new pod containing. Again, get pods. So you can see that they replaced the old one with a new one, and everything is working just fine, because up until this moment the servers in the pool, which are 2, we have 2 nodes, are enough for these pods to run. So let's, instead of doing again the load testing, let's use the QCTL scale option, which takes replica as an input. I think it takes 2 dashes here. And I will just ask him, the Kubernetes cluster, to have 3 replicas of the deployment, which was the name of rating API. So like this, it's simply, I am telling Kubernetes, please scale, give me 3 more, or like 2 more pods, a total of 3 API running pods. It should work, yes indeed. So when I get pods now, you can see, alright, that's what I wanted to show you. So here you can see that it added 2 more pods to match the 3 pods requirement, but we don't have enough servers or nodes underneath in the cluster to contain this demand. Back to the portal, here I will show you how can you scale up your nodes in order to meet this new demand. So if you go back to the node pool setting, and you will see that here is your agent pool. Remember, we have your Kubernetes cluster can have up to 10 pools, node pools, which is just a set of servers, and for each node pool you can have up to 100. So here in the 3 dots here, I press on it and I press scale. And here it allows you to see 2 options. There is manual and auto scaling option. The manual, as the name indicates, you can just put here the manual number that you want, and you can go, as you know, up to 100 nodes. And you can also configure auto scaling, the minimum and maximum node count, which will be updated according to the load coming from the pods. So here we're gonna keep it as 2. I just wanted to show you here that you can do manual and auto scale, which shows you the minimum and the maximum amount of nodes. Manual, you specify exactly how many nodes you want, and you go down and you press apply. And that's how you scale up and down your clusters. Of course, if you try now to add 3, for example, you will get an error because this is a free subscription. You cannot get more than 2 nodes of this size. Before we go to the next video, let's make sure that we restore the original configuration. We go back to the YAML file, make sure that we are back at the 500 and 250 for request and limits. And we go back to the command line because you remember that we have now, if you do Cube Ctl get pods, we will have 3 pods at least. Yes, 3 pods at least for API, rating API. What I need to do now is to restore the original configuration. The simplest way to do it is to just delete the deployment, which is delete deployment rating API, and then again you apply the updated one, and this will make sure that we only have one rating API running.
Be focusing on Azure Monitor that allows you to get the monitoring data out of your cluster. High-level Azure Monitor allows you to be able to collect and analyze and act on telemetry and data you collect from your cloud on on-premises environment. So it allows you to get some metrics like CPU utilization, memory utilization, and I really like on the official page of Microsoft, they have a really nice high-level overview about what Azure Monitor is. Very powerful platform. So here it gives you insights, meaning some metrics and data for your application. Application can be hosted on AKS, on a virtual machine. It doesn't really matter where. All of the services in Azure is supported by Azure Monitor. With this data, it allows you to visualize it, make some dashboards, and analyze it using log analytics, and respond, meaning that you are able to create alerts like send me an email if the CPU utilization is smaller than or bigger than certain amount, 50% for example. And it integrates with business processes, so you can have an API that communicates to your on-premises system, or you can do a workflow using Logic Apps. So in short, it's a very powerful platform that helps you get all of the information of your cluster, in this case Azure Kubernetes cluster. And in this video, we're going to be talking very high level about what Azure Monitor can provide to you in the context of AKS.
We are back to our portal. In order to access Azure Monitor for your AKS cluster, you have 2 ways. First, in the overview screen, you can find here 2 buttons that talks about either monitor your container or view logs. You can press on it here, or you can directly go through the monitoring section and press on Insights. So let's do that. Once you go to the first screen of your Azure Monitor, you will find already some dashboards are built for you, which is very interesting. It gives you the node level information, so the CPU utilization, memory, node counts, and pretty much everything that you would like to know on a high level from the nodes. It's already built for you. And here you can choose which kind of information you would like to draw in this dashboard. For now, let's keep it minimal, as average and maximum. What's interesting here also, you can allow the live data. And here you will receive live data, as you can see, with a period of 5 seconds, you can go down to 1 second. And you can already see the live data inside your container, the application, when there's higher demand or lower demand. For the sake of the demo also, let me go back to my command line here. Remember here we had a load testing before. I'm using the same command. So just sending multiple information, multiple requests towards, let me just stop it and show it to you. It just requests towards your load test API inside your application, and let it run. And if I go now to my portal, I can see here that already the performance is increasing. CPU utilization is increasing. The memory utilization is increasing. It's real time. And if you go back and stop it, you'll also see it going down, but it will take a little bit more than 1 second here to show it. So it's not very accurate. I go back here and I stop it, and ideally within 1 second it should go back. But here you can see If I go up, you can see it's still, even if it's 1 second, the granularity, it's still going up, and after a while it will go down, but there is kind of 10 seconds delay or something. So I will close this for now, and let's see other blades here, other tabs here. I go to the health, and here it gives you a lot of information about the Kubernetes infrastructure health and the node health. Here it tells you like the current state, it's healthy, everything is green, as you can see here. And here all of the services that are running on the master. The master node in AKS or Azure Kubernetes Service is given for free. This is part of the offering of the AKS from Microsoft. You can also see the nodes, and here it gives you, first of all, the first level is the pool, and we have only one pool, and we have 2 nodes inside of it. Let me make it bigger for you to see the overall view. So here it gives you the overall health indication of the node level. And if we zoom a bit more, you can see here, it tells you everything is perfect. And we are now monitoring the CPU utilization, memory utilization, and overall status. And this is 3 metrics that are monitored by default. Okay, let's see the next tab. Here we have the nodes, and it gives you a high-level view also about the nodes. So we can see the containers. It's running 20 containers so far, because also it runs some built-in Kubernetes containers to monitor and communicate with the master. And you can also see the uptime and a lot of other information, and you can dig deeper to the containers or pods that are actually running inside. But what's interesting here, I would like to show you this preview feature. By the time you're watching this, maybe it's already in general availability. So let's press on this. It opens you console where you can get live metrics and also events that's happening on the node level. So here there's no new data on this one because we are selecting this container, but let's select the high level node and press again on view data. And here you can see, you get neat high level details about what's happening from the management point of view on this node. For me personally, the most used tab here is the container tab. And this one, it gives you information about all of the pods that was there, existed before in your Kubernetes cluster. And it gives you live data here also regarding the actual running pods in your cluster. For example, let's go and find the rating API. This is the rating API which is currently working. So I press on it, I press on view data. And let me zoom in here to see. So you have by default, you have the log tab and the events tab. The events, what's happened when actually that was creating. So have here that it's pulling the image from the Azure Container Registry. It was successfully built, it's created and started. And the logs here by default, it gives you the high level view. It doesn't give you what the application is doing itself while running, but what's happening on top of the container or the pod itself. If I go back here and rerun my load test, and I go back to the console, it gives you live data about what's happening. Here you have a GET request on the API load test. Stop this one, go back here, and you can see that the only request which is happening now is the health probe. If we go back to the cluster level, here we have some metrics which is ready-made for you, as I showed before. But what if you would like to know a certain metrics that doesn't exist here? That you can configure under metrics. If you press on it, you will get a nice dashboard here that tells you what is the scope, which is in this case the Kubernetes cluster. What is the metric namespace? It could be a standard one or custom, which is based on logs that you collect. Let's keep it for now a standard, and you can select the metrics. And this is very limited, as you can see metrics is. And if you select custom, you can even increase those. But for now, let's just see, for example, the disk busy percentage. And it shows you the nice graph about the disk busy percentage on an average level. You can see the minimum, the maximum level, and you can plot it all.